So this is to demonstrate the IMS server virtual lab for load test. This is the Protocol Engine main UI, which is accessed using a browser. We're going to run the virtual lab. There are multiple products installed here, but the one we're interested in is this one here, which is a virtual lab. And it has three components that it's going to run. It's going to run a server emulator, an originator, and a terminator emulator, so three modules. Within there, we have an environment file which allows you to set parameters for your local test run, like IP addresses and pulling called party numbers and transports and things like that. Let's choose TCP as the transport, and I'm going to run 10 endpoints. So I can save this. To load this, I can click this button here, and that will load the Protocol Engine. And here are the three modules we just looked at. And we get some user interface widgets. Here we can set how many instances we're going to do. I'm going to do 10 instances. Each call is going to be for 30 seconds. This is values in milliseconds. We're then going to wait about 2.5 seconds before we start the next call for that same user agent. And we're going to start the user agents 1 second apart. That's going to give us a caps of 0.31 and a BHCA. So if we change some of these values, you'll notice the caps and the BHCA will change. Right, so I'm going to do a remote capture in Wireshark, which I can do using our remote capture utility, which I downloaded. So that will launch and it will spawn Wireshark, which is now looking at all the interfaces on the Protocol Engine. Also down on the UI, we have some helper widgets, which shows us that we have the terminators have already registered and are sitting listening. If I click the start button on calls, you'll see that the originators register and then make a call. So these are currently in call. And if I look at Wireshark here, my call's establishing. And if I've also got RTP. So we now have 20 UAs involved in 10 calls. So there are 10 active calls. And then after our length, which is 30 seconds, we should see these calls drop out and then wait a couple of seconds and then start up again. So these calls are currently in progress. While we leave those running, we'll have a look at an active journal, which allows us to see things like, I'm going to collapse the setup parameters, and I'm going to turn on the graphs. So we can see things like here are the 200s to the buys. So we have an active count over time, and we have that for all the different messages that are involved. So we can see at a glance if we got like 486s or 403s or whatever, we'd see them in here. And once we finish this test run, we'll have this available to be able to export to a PDF for a status of the test run. We also have individual call records, CDRs, EXRs. So here, for example, it says that there are 2 correlated CDRs, one for the originator and one for the terminator. And the originator is striped because there was a KPI violation. So the delay in media was 1.7 seconds, and our maximum is set to 1,000. So you can see at a glance, if we set the thresholds to what we want to measure, you can see at a glance if any of the calls are outside of our set parameters. We should also have in here RTP. Yep. So we have RTP with things like R value, mask jitter, latency, packets, etc. And these are all correlated by call ID. So if I click on this call ID, we should have 4 records We only have 2. We only have 3, but we should have a terminator there as well. So now when I'm done, if I hit the stop button, it will let calls in flight continue, but it won't start any new ones. So here are the calls hanging up. Last message was 200 by, and now we have 0 active calls. And we have total control over the messages that we generate. So if I go into our template for our invite message, for example, our invite message is set up with name value pairs for each SIP header that we're using. So we can either change the value in an existing one, or for example, I can add a new one. So if I just duplicate this, I could add a SIP header called anything, validate, and set its value to hello world. And if I save that and then we run the restart the protocol engine, I'm just going to clear out my Wireshark so I'll be able to see it more easily. And this time I'm just going to run 1 call. So my 10 terms have registered and are sitting listening, and now we should just get 1 call going. And if I look at that call in Wireshark, the invite message has a new header called hello world. So we can change the value, we can add new headers, we can change headers. So we have total control over the messages that are sent.